Welcome to all. I am Dr. S. Sukumaran, Associate Professor of Computer Science, Erode Arts and Science College, Erode. In this tutorial, we are going to see about the digital image processing. An image, we can get it from a camera or telescope, microscope, or any other type of optical instrument. Displays a continuously varying arrays of shades and color tones. So this is known as a continuous tone image or analog image. Simply an image provides an information. An image is a two-dimensional function that represents a measure of some characteristics such as brightness or color of a viewed scene. An image is a projection of 3D scene into a 2D projection plane. It can be defined as a two-variable function f of x comma y, where for each position x comma y in the projection plane, f of x comma y defines the light intensity at this point. A digital image is a representation of two-dimensional image as a finite set of digital values called picture elements or pixels. Some of the examples of digital images are natural landscape, poster graphic, barcode, fingerprint, X-ray, microscopic slide, satellite image, radar image. A digital image can be represented in a variety of formats. The common formats are black and white or grayscale, which uses one values per point or pixel. Another format is RGB format. Here we have to use three values per point or pixel. The advantages of digital images are the processing of images faster and cost effective. The digital images can be effectively stored and efficiently transmitted from one place to another. Copying of a digital image is easy and the quality of the digital image will not be degraded even if it is copied for several times. Whenever the digital image is in digital format, the reproduction of the image is both faster and cheaper. It is an example of a color image represented by RGB. Each pixel contains a vector representing red, green and blue components. It is an example of binary image or black and white image. Here each pixel contains one value, either 1 or 0. So 0 represents the black and 1 represents the white. The processing of an image by means of a computer is generally termed as digital image processing. Here we have to use the certain algorithms to alter the input image to create a new image. The input is an image and also output is an processed image. It improves an image for human interpretation in the way image displaying or printing, image editing, image enhancement, image compression. The key stages in the image processing are image acquisition, image enhancement, image restoration, morphological processing, segmentation, representation and description, object recognition, image compression, and color image processing. The term image acquisition refers to the process of capturing real-world images and storing them into a computer. Conventional photographs in the form of negatives, transparencies, or prints can be scanned using a variety of scanning devices. The image captured by a sensor and digitized in the output of the camera or sensor is not already in the digital form using analog to digital conversion. Image enhancement. The objective of image enhancement is to improve the interpretability of the information present in an image for the human viewers. An enhanced algorithm is one that yields a better quality of image for the purpose of some particular application, which can be done by either suppressing the noise or decreasing the image contrast. The enhancement algorithms are employed to emphasize, sharpen, or smoothen image features for displays and analysis. Enhancement methods are application specific and often developed empirically. Image enhancement technique can be classified into two categories: spatial domain and transform domain method. The spatial domain method operates directly on pixels. The transform domain method operates on Fourier transform of an image and then transform to spatial domain. The image restoration process is to improve the appearance of an image. This leads to mathematical or probabilistic models. That enhancement, on the other hand, is based on the human subjective preferences regarding what constitutes a good enhancement result. In the morphological processing, we have to use tools for extracting image components that are useful in the representation and the description of shape. In this step, a transition from the process that output images to processes the output image attributes. The image segmentation refers to the process of partitioning an image into group of pixels which are homogeneous with respect to some criterion. Different group must not intersect with each other and adjacent group must be heterogeneous. So segmentation algorithms are the area oriented instead of pixel oriented. The result of segmentation is the splitting of the image into connected areas. Thus, segmentation is connected with dividing an image into meaningful regions. Generally, images require a lot of space as image files can be very large. They also need to be exchanged among various imaging systems. Hence, there is a need to reduce both the amount of storage and the transmission time. This leads us to the area of image compression. Image compression deals with the algorithms and techniques for compression of an image. Color image processing requires many supporting devices including cameras and color monitor. A color image is a digital image where every pixel has both color and intensity information. Color image is the acquisition is the first step in the color image processing. In color images, the pixel color can be obtained by mixing the primary colors red, green, blue. Various color models are used for representing the image. Some of them are RGB, red, green, blue model, and CMY, cyan, magenta, yellow color model. CMYK, cyan, magenta, yellow, black color model used for color printing. HIS, hue saturation intensity model, which corresponds closely with the human, describe the and interrupt the color. Digital image processing is widely used in different fields like medicine, forensic, remote sensing, communications, and automobile field. In medicine, digital image processing technique like image segmentation and pattern recognition is used in digital mammography to identify the tumors. For example, projection of image transaction axial tomography and medical images that occur in radiology, nuclear magnetic resonance NMR, and ultrasonic scanning. In forensic, security can be enhanced by personal identification. Different biometrics are used such as face, fingerprint, iris, and vein pattern. The use of digital image processing in remote sensing is the use of remote observations to make useful inferences about a target. Remote sensing is used increasingly to provide data for diverse applications like planning, hydrology, agriculture, geology, and forestry. In communication, we use DIF for video conferencing, which helps the people in different locations to interact lively. For video conferencing to be effective, the information has to be transmitted fast. For that, we have to use some of the compression techniques. In the case of automotives, we use the digital techniques in the night vision systems, which helps to identify the obstacles during night time to avoid accidents. And also infrared cameras are invariably used in night vision systems. The image processing techniques commonly used in a night vision system include image enhancement, boundary detection, and object recognition. Here we have an example operation of noise removal. In the first image we are having a noised image that is to be denoised by some of the noise removal algorithms. After that we get a clear image. This is also an examples for the noise removal. This is an example of the contrast adjustment with a different constant contrast levels, low and high contrast levels. This is an example of edge detection process. Here the object edges are detected for the application of image. Here is an example of region detection and segmentation. In the medical image we have to identify the region, particular region, and as well as segment the image. This is an example of image compression. The original image we are having a 2.1 MB. After the compression, we get the image in the size of 308 KB, which is 50% compression. We have to make it by using JPEG method.